Now, two balls of equal masses are thrown upwards along the same vertical direction at an interval of 2 seconds with the same initial velocity of 40 meters per second. Then these collide at a height of what is the question. G is to be taken as 10 meters per second square. Notice the environment is this. This is the ground. I am throwing up one ball, and after having thrown up one ball, the second is also being thrown up. So when this ball is already here, maybe I am going to throw this up. The question is, then these will collide at what height later? Notice that one will continue to go up, and the second, the one is going up, and the second is starting its journey 2 seconds later. We need to consider the displacements S1 and S2. If this is the first ball and this is the second ball, that is the one, then I can say ut minus plus half at square, and this is ut plus half at square. I am writing the same thing to start with, but you must realize that this is T1 and this one, this is T1, this is T2, and this is T2. Now the difference between T1 and T2 is that if this is T1 minus 2. So I can take, if I take it as T and T minus 2, then I'll write the equation as S1 is equal to ut plus half at square. Now it is being thrown against gravity, so I'll make it as minus g, and S2 is going to be ut minus half g ut2, that is t minus 2 minus half g t minus 2 whole square. Now we want these to collide at a particular height. So if they meet at a certain height h, then these two will have to be equal. So I will have to have S1 is equal to x2. So I'll write ut minus half gt square is equal to t minus 2 minus half gt square. Notice that this is going to be t minus 2 whole square. Now you will see that if I expand it, I'll get ut minus 2u minus half g t minus 2 whole square. So now ut will cancel with this, giving me half gt here. So this is minus half into 10 into t square. So I'll get it as this, and this is going to be minus 2 into 40, that is minus half of 10, and this is t minus 2 whole square. Now this solution will give you that t will be equal to 5 seconds. If you solve this, you will get a t equal to 5 seconds, and when I put this value of t equal to 5 seconds in one of the equations, I will get my expected height, that is S1 is equal to 40 into 5 minus half of 10 into 25. This is 200 minus this is 5, so 125. So answer is 75 meters, and that is going to be my answer required, which is B. So the answer is B. A particle starts from rest with uniform acceleration a. Its velocity after n seconds is v, and the displacement of the body in the last 2 seconds is what is required. Notice that when a particle starts from rest, we are going to write v equal to u plus a t, and since u is 0, I'll write v is equal to a, and this is my n seconds, I'm going to write this. So acceleration is going to be v by n. This is what I'm going to keep in mind. Then I want a displacement in the last 2 seconds. So this again I will be using half this at square because initial thing is 0. So this will come into the picture. So I'll be using half a, and the next part is, instead of t now I have to do it. So minus half t, this t minus 2 square, that is what is required. So I get half a t square minus half a t square minus 4n minus 4 plus 4. This is what I get. So I get half at square minus half at square. Now notice that this will be plus 2an plus 2an and minus 2a is what I get. This will cancel. Notice that an is nothing but v. So I'll say 2v minus 2a is what I get. And if I take out 2a common over here, I'll get n minus 1. If I substitute for a, I get 2v by n minus 1. This is my displacement, and that is obtained here a, b, c, d. Notice that the option is a. So the answer is a. Is a in this case. This is the answer. Stop. Now, two trains A and B, 100 kilometers apart like this, are traveling towards each other. A is traveling this way, B is traveling this way, towards each other on different tracks with same starting speed of 50 kilometers per hour, and this is also 50 kilometers per hour. The train A accelerates at 20 km per hour square, and train B retards at the rate of 20 kilometers per hour. So when that happens, the distance covered by the train A when they cross each other is what we need. Notice that u1 is equal to 50 kilometers per hour, and that is equal to minus u2 because of the opposite direction. Now coming to accelerations, a1 and a2 both have the same magnitude, 20 kilometers per hour square, but the relative acceleration is 0. So initial acceleration is 50 minus 50, 100 kilometers per initial velocity. Relative initial velocity is this kilometer per hour, and relative acceleration is this. I must find out the distance covered by train A when they cross each other. If they cross each other at time t, then that will be given by t divided by u. My d is 100 kilometers divided by u is going to be 100 kilometers per hour. So t is going to be 1 hour. So after 1 hour, they will cross each other. And since I am interested in knowing distance covered by train A, I will say that S of A is equal to ut plus half at square. In this equation, now I am writing u is equal to 50 into 1 hour plus half. U is now going to be 20, and this is going to be 1 square. So this is going to be 50 plus this is 10, so 10, that is 60 kilometers. This is 60 kilometers, and this is the answer D. This is the answer D which you find here. So understand the difference is we must calculate relative initial velocity, which is 100 kilometers. Relative acceleration is going to be 0. But ultimately in my value calculation, I will be needing these values because this is the absolute acceleration, or we can say non-relative acceleration of the train A, and that I must substitute to get the value equal to 60 kilometers. Answer D.